Have you ever paused to watch water bubbling away on the stove, or noticed how ice cubes slowly disappear into a puddle in your glass? These simple moments might seem ordinary, but they're actually the opening acts of a magic show happening right in your kitchen. It's a performance where everyday objects transform before your eyes, shifting shapes and states as if by magic. These everyday changes reveal a fundamental secret: matter isn't fixed. It can become a solid, a liquid, or a gas, all because of two invisible but powerful forces at work. Think about chocolate softening in your hand, or fog creeping across a cold window pane. Even the simple act of breathing on a chilly morning creates a visible cloud, showing you this transformation in action. All these are examples of matter shifting from one state to another, right before your eyes, often without you even noticing. This hidden dance is choreographed by temperature and pressure. When things heat up or cool down, or when the air around them changes, tiny particles get new instructions, sometimes to huddle close, sometimes to spread out and move freely. You don't need to be a scientist to appreciate this. It explains why your breath fogs up a window, why water droplets form on a cold glass, or why your kitchen fills with steam when you cook. It's also the reason a pressure cooker can turn tough ingredients tender in minutes, harnessing the power of pressure and heat to change the very nature of food. These simple rules don't just apply in your kitchen, they govern everything from the clouds drifting overhead to the formation of diamonds deep within the earth. By exploring these changes, you'll start to see your kitchen, and the world around you, in a completely new light, full of wonder and hidden science. It's all about energy and space, particles holding tight in a solid sliding past each other in a liquid or flying free as a gas. Each state is a new chapter in the story of matter, so let's pull back the curtain together and discover the science behind the everyday magic of matter, right here in your own kitchen. Imagine all matter as a party of tiny particles, each one buzzing with its own energy and personality. Everywhere you look, from the chair you're sitting on to the air you're breathing, these particles are constantly moving, interacting, and creating the world around us. It's like an endless cosmic dance happening on a scale too small for our eyes to see. In solids, particles are packed tightly together, barely moving, like people sitting in assigned seats at a formal event, unable to wander off. They vibrate in place but don't have the freedom to roam. This close arrangement gives solids their definite shape and makes them sturdy and hard to compress. That's why solids keep their shape even when you move them or stack them up. Their particles are locked in a regular pattern, making them reliable and strong. In liquids, particles have more energy and can slide past each other. Imagine friends mingling on a dance floor, weaving around but still staying close. Liquids don't have a fixed shape, but they do have a definite volume, and their particles are always in motion, flowing and swirling. That's why liquids flow and take the shape of their container, whether it's a glass, a bowl, or a riverbed. They adapt, but they don't spread out endlessly. In gases, particles have so much energy they break free from each other, bouncing everywhere, like a wild party where everyone's running around. Gas particles move fast and far apart, filling up any space they can find. That's why gases expand to fill any space, whether it's a balloon, a room, or the entire atmosphere. They're always on the move, never settling down. Under extreme conditions, matter can become plasma, super energized, with electrons ripped away from atoms like the chaos of a lightning storm or the blazing surface of the sun. Plasmas are found in stars and neon signs, and they're the most energetic state of matter we know. Or if you cool particles down to nearly absolute zero, they can form a Bose-Einstein condensate where they all act as one giant superatom, moving in perfect harmony. This state is so strange it only exists in special labs. These exotic states are rare, but they show just how wild and unpredictable the particle party can get. Matter isn't limited to just solids, liquids, and gases. There's a whole universe of possibilities. Every state of matter is just a different way for particles to move and interact, shaping everything we see, touch, and experience in our universe. What makes particles switch states? Temperature. Temperature measures how much particles are moving, their kinetic energy. In cold solids, particles barely wiggle, locked in place. Add heat, and they vibrate more, eventually breaking free to become a liquid. More heat, and they move so fast they escape as a gas, like water boiling into steam. Take heat away and the process reverses. Gas condenses to liquid, liquid freezes to solid. Everyday examples: ice melting, water boiling, dew forming on a cold glass. It's all about energy. Add it, and particles move more. Remove it, and they slow down. The cycle of melting, boiling, condensing, and freezing is the story of temperature at work. Temperature is the main driver of matter's hidden dance. When matter changes state, it's called a phase transition. Melting turns solids to liquids. Freezing does the reverse. Boiling or vaporization turns liquids to gases. Condensation brings gases back to liquids. Sometimes matter skips a step. Sublimation is when a solid turns directly into a gas, like dry ice. Deposition is the reverse. Gas to solid, like frost forming on a window. Each substance has specific temperatures for these changes, its melting, freezing, and boiling points. Phase transitions are an energy tug-of-war. Heat breaks bonds, cold pulls particles together. At the melting or boiling point, energy goes into changing state, not raising temperature. That's why boiling water stays at 100 degrees Celsius until it's all steam. Phase changes are everywhere, quietly shaping our world. Temperature isn't the only director. Pressure plays a huge role too. Pressure is like squeezing the party, giving particles less room to move. At higher pressure, it's harder for particles to escape, so boiling points rise. On a mountain, lower pressure means water boils at a lower temperature. In a pressure cooker, trapped steam raises pressure, so water gets hotter and cooks food faster. Pressure can also affect melting. For most substances, more pressure raises the melting point. Water is an exception. Pressure can make ice melt at lower temperatures, helping ice skates glide. Pressure and temperature work together, controlling when and how matter changes state. This partnership shapes everything from cooking to skating. The hidden dance of matter is a duet between heat and squeeze. Scientists use phase diagrams, maps showing how temperature and pressure affect a substance's state. Picture a graph: temperature on one axis, pressure on the other, with regions for solid, liquid, and gas. The lines between regions are phase boundaries. Cross one, and the substance changes state. The triple point is where all three states coexist: solid, liquid, and gas in perfect balance. For water, this happens at a very specific low pressure and temperature. The critical point is where liquid and gas become indistinguishable, a supercritical fluid. Supercritical fluids have unique properties used in things like decaffeinating coffee. Phase diagrams are the ultimate cheat sheet for predicting matter's behavior. They show all the possible outfits a substance can wear. With them, we can predict and control phase changes in science and industry. This dance of temperature and pressure is the invisible force choreographing our world. From the fiery depths of the Earth to the farthest reaches of outer space, it's a constant interplay, shaping everything we see and touch, and even things we can only imagine. Deep beneath the surface, diamonds form under unimaginable pressure and searing heat, transforming simple carbon into the hardest and most dazzling gem on Earth. This process takes millions of years, a testament to the patience and power of nature's forces. Far above, in the heart of stars, matter exists as plasma, an extraordinary state where atoms are stripped of their electrons. Here, under crushing pressure and extreme temperatures, nuclear fusion ignites, releasing the energy that lights up our universe and makes life possible. On Earth, we harness these phase changes in remarkable ways. Liquid nitrogen, colder than any winter, freezes objects in seconds. MRI machines use superconducting magnets cooled to near absolute zero, letting us peer inside the human body with incredible detail. These technologies rely on our understanding of matter's transformations. Even the fizz in your soda is a product of this science. Carbon dioxide gas is dissolved into the liquid under high pressure, only to burst out in a flurry of bubbles when you pop the can open. It's a tiny, everyday explosion of physics in your hand. Rain falling from clouds, steam rising from your morning coffee, the sparkle of gemstones, and the twinkle of distant stars. All are made possible by the hidden dance of matter as it shifts between states. Every phase change, whether it's ice melting or water boiling, is a performance of energy and pressure at the molecular level. Molecules break free or come together, always moving to the rhythm of nature's laws. The science behind these changes powers our technology, drives our industries, and shapes the very fabric of our daily lives. From the food we eat to the energy that lights our cities, it's all connected to this fundamental dance. So next time you watch an ice cube melt or see water boil, remember, you're witnessing the universe's greatest show, a spectacle that's been unfolding for billions of years. The dance of matter is everywhere, beautiful, powerful, and endlessly fascinating. It connects us to the cosmos and reminds us that in every moment, we are part of something truly extraordinary.